Hello, my name is Paul Tompkins, and I'm the flight team lead for the Lcross mission. Lcross stands for Lunar Crater Observation and Sensing Satellite. And as flight team lead, I lead the team that operates the spacecraft from a mission control center here at NASA Ames Research Center. Our mission objective is to look for water at the lunar poles, perhaps contained in permanently shadowed craters there. We launched on June 18th of this year, and our impact is scheduled for October 9th, 2009. We have Lcross mounted atop the Centaur vehicle, which is now spent and depleted. And over the course of 3 months, we'll guide this upper stage into a crash course into the lunar South Pole. When it impacts the moon, our spacecraft will be detached and will be watching the impact and looking for signs of water. So here we have an animation of the full Lcross mission. We swung from the Earth all the way out to lunar distance, and just as the moon goes by, it threw us into this super high inclination, highly elliptical orbit around the Earth, but at about lunar distance. And what that allowed us to do is phase our orbit such that in 3 months we'd come back on the moon again and have a direct impact on the South Pole. While we were sitting on the pad in Cape Canaveral, our Centaur upper stage absorbed water from the atmosphere. And that's a natural thing because the Centaur is very cold and collects water and then turns it into ice. The interesting thing is that even though space is a vacuum, the water can sustain itself there if it's cold enough. The reason that's a problem is that, first of all, if we bring water from the Earth's surface, it could interfere with measurements of lunar water in the permanently shadowed craters. And so we want to remove that ambiguity. Secondly, the water, if it's exposed to sunlight, will escape. And as it escapes, it can cause an impulse onto our spacecraft, which will actually disturb our trajectory as we near the lunar surface. So on July 30th, we conducted a maneuver called cold side bakeout, which involves turning the spacecraft from its normal orientation pointed towards the sun 180 degrees to face the back side of the spacecraft to the sun for the first time in a long time. Once it gets exposed to that sunlight, it'll warm up, and those water constituents will start to bake out of the surface of the Centaur. And our objective is to get most of that removed such that when we have impact, we won't have any trace of water on the surface, and it won't cause a disturbance of our trajectory. So now that we're 1/3 of the way through our mission, interestingly enough, the specific crater target is not yet designated. About a month and a half before impact, a group of scientists from Lcross and from LRO and other missions will gather together to make the final decision for our specific crater target. And by impact minus 30 days, we'll have our answer, and we will broadcast that to the public. Lcross impacts the moon on October 9th. I want to make sure everyone checks out the Lcross website to view in person, live, the impact imagery as it comes back, streams back from the spacecraft. We're impacting at 11:30 GMT, which is 4:30 a.m. Pacific time. Please take a look at the website and enjoy.